And the big one? Congruency, similarity, you also revisit this one. So, you can also use gradient. So there's two ways. So first thing, if we use similarity, this is 2, right? The whole thing is 8. Correct?
13 plus 8 is
yes. Can you see the small triangle, the base here is 2. This one is 8. You just take the difference between 21 and 13. Okay, the height here is unknown to me. I'm supposed to find this speed. So I let this be V. Okay? And then this whole thing is H. So if I compare the ratio of the height, so V over 100, it should be equal to the ratio of the base, which is 2:8. I try to always put the V on top so that when I cross multiply, it's easier for me to solve. Okay?
How do you even get the 100?
There, from here. This one is 100, ma? So the height is 100 already. So you cross multiply, you 2/8 of 100, so you get 25. So this is part A. So just using similar triangle. Or like what Hashish said just now, just use gradient, right? So gradient of the full line, this full line, should be the same as the gradient of this partial line. So rise over run. Okay, so this rise over run is 4 over 2. It should be equal to 100 over 8. Same. Okay, so you will also get the same thing, 25. So this one is using gradient, same gradient. 21 minus 13. So same gradient, or you can use similar triangles. So you see what works better for you. Okay? Then next one, calculate the distance traveled for the first 13 seconds. So this one just use area of the graph under the curve. So how to find the whole area? Half times base times height, this piece. This piece, length times breadth, so 3 times 30. This piece is like your trapezium. Half times sum of parallel lines times the height here, 5. So this is the total distance traveled. So this one, just go and find area of all the 3 shapes. Part A, part B, part C. Part A, part B, part C. Use area formula to find. So 5 times 30 times 0.5. Okay, you will get 490. In this case, meters. Okay, last one. They say is the acceleration for the first 5 seconds greater than the acceleration for the last 5 seconds. Which one is greater? Which one is greater acceleration? The red one or the blue one? The blue one, because it has a steeper gradient. Or you can go and calculate. So you can say the gradient at time equals to 8, 13 is greater than the gradient at 0 to 5. Okay, therefore acceleration is greater. Okay, so you just have to explain to me that the gradient here is bigger than the gradient here. That's why acceleration is greater. So actually most of the concept I've already explained to you. Distance time graph, you just relate to the gradient is speed. Speed time graph, the gradient is acceleration. The area is distance. So the whole chapter, this is the most important thing already. The last part is the graph sketching. And it has not been tested for the past 5 years. Okay, but you still need to learn that. So for those of you who have not done the HBL, you go in, they will show you the graph changes. So go and catch up on that, but tomorrow we will finish that. Okay. How many chapters left for WA3? We haven't fixed WA3. Okay, but I intend to try to finish congruency similarity by the end of this.
Similarity should be simple, right?
Congruency got 5 tests. That means you just memorize the 5 tests and apply. Similarity got 3 tests. So total 8 tests, right? Then after we learn about the tests, we learn about the ratio of area and volume. So that's the application part. So the whole chapter just got these 4 important concepts. And then binomial theorem, I told you all, right? You all will learn during the holiday. Then we will be just on task. Can ah? Can. Steeper is also fine. Yes. The French students, I will load the video and then you will. I give. Oh, you're leaving today, huh? Okay, I'll put the notes in my locker so you all can bring to. No, you all come back. You all during June holiday, you all learn yourself. Yeah. No, don't bring to France. Just to recap, distance time graph. Okay, when you see that the vertices or the axes, x and y, this one is distance and this one is time. You know it's a distance time graph. There will be forward journey. Okay, and then it stays at rest for a certain point of time and then it returns. So usually this is what they ask for. So what they can do is they can say this is 100 meters and then maybe this whole duration is about, I don't know, 20 seconds, for instance. So what are the possible things they can ask you here is when you have a distance time graph, they can ask you for the speed. So the speed, okay, for the first 8 seconds. So speed is gradient for distance time graph because it's d over t. Okay? So if you want to find speed, you will use 100 divided by 8. So remember for distance time graph, gradient gives you speed. Okay, this is the important thing. Next thing is if they ask you for average speed. So they like to ask average speed for distance time graph. So you need to give me total distance divided by total time. So although it looks like going from here to here, the maximum is 100, you don't use 100. Because forward journey is 100, return journey is another 100. So total distance is 200. So this one, take note, includes to and fro journey. So you double the distance that you see here because you go forward 100 meter, you come back to the original point another 100 meter. Then total time taken is 20 seconds. But remember, this total time includes the rest time. So that's the only thing you need to take note of. So from this, that's the usual thing they can ask you for distance time graph. Quite boring, so they really like to ask distance time graph. If it's displacement, then you know that the distance covered ignores the displacement. When you consider the distance, you come back and you cancel off. So the distance traveled is 0. Yeah. So if you go there and then you come back, displacement is 0. So they rarely involve displacement here. It will be distance. Okay, next one is speed time graph. So when you see that the axis becomes speed and time, then when you have the same kind of graph, okay, same kind, the gradient tells you acceleration. Okay, so this part here that is moving up, we say is acceleration. Okay, this part here that is moving down, we say is deceleration or retardation. Because the gradient is negative. Okay, or retardation. So it's just the terms for it, but basically you are finding the gradient. Okay, you are finding the gradient. Okay, then another thing you need to know is if you want to calculate distance, you find the area under the graph. So distance is area under the graph.
This one.
Yes.
The straight line is constant.
Yes, correct. Under the graph. Okay? So, okay, let's go to the other type of question in terms of the graph behavior. Acceleration they will ask, but when they ask, is asking you for the gradient. If they want to ask you for the other acceleration time graph, right, you will realize that your graph all becomes step functions. Okay, step function like that. So they rarely ask you acceleration graph. Not really, because it's like that. From here to here, then like this.
This one.
Yes.
So let's say you've got like the question they ask you for the straight line, whether there's acceleration. No, right? Because
They can ask you to describe the behavior of the vehicle. Then you have to say,
okay.
yeah, like very physics. Yes. Why? Going up? Like that. Then they won't ask you to find the acceleration because it's increasing. Then they cannot ask you to find the specific acceleration. This part, decreasing. This one we'll talk about it in the next part. Okay, if the graph is increasing at an increasing rate or decreasing at a decreasing rate. So here, we will talk about it slowly. Okay, so this first thing you look is always the axis. Speed, time graph. So you need to recall that gradient tells you acceleration. Okay, and then the area under graph tells you distance. So these are the two things. Once you see speed time graph, you know you will be asked these two things. So first thing first, it says, can you find the acceleration during the first 10 seconds? So that means they are asking you for the gradient of this line for the first 10 seconds. So in order to do that, just find gradient. So gradient of the line AB is rise over run. Okay? So since this is meter per second, you divide by second, it is meter per second square. So acceleration unit is meter per second square. Okay, part 2, they ask for the deceleration for the last 4 seconds. Okay, take note, because they already acknowledge that it is deceleration, the answer is positive. So when they ask for the deceleration, it will be rise over run. So 20 divided by 4. So 5 meter per second square. However, if I change the question, what is the acceleration during the last 4 seconds? Then you give me negative. Okay? So you take note. If the question already specify that they know that it's going downward, you just give me the actual value will do. Don't need to give me the negative one. Then you'll be marked wrong. Yeah, so deceleration must be the positive one. Okay, this whole chunk of words is just telling you that distance is area under graph. Okay, distance is area under graph, which is what I've written here. So part 1 says, can you find the distance traveled when the car accelerates? So the car accelerates at this point only. Okay, so when it's this, then you will find the area under the graph, which is half times base. The base is 10 here. Okay, times the height, 20. So 100 meters. Okay, Okay, so you just follow the question, what the question wants, and then just find the information accordingly. Second part is the distance for the decelerating part. So go and find this area. So half times base times height, so 40 meters. Okay, so if they want you to draw the distance time graph for the whole journey, right? Then let's just try to translate according to this section. Okay, I usually want to follow the exact same dimension that is given. So let's say this is 0, this is 10, okay, 12, and then 15. So they want you to draw the distance time graph. So first thing first, this is your vertical axis. You know this is distance, this is time. So you ask yourself, for the acceleration first second, the distance traveled is 100 meters. So you know at the end of 10 seconds, your end point must be at 100. And you started off with distance 0. Okay? Then next part, it's for this next portion here. Okay, although it was not accelerating. Okay, it was moving at a fixed velocity, right? There was no acceleration at that point in time. The car was still moving. So the distance traveled for this portion is just the area of the rectangle, which is 2 times 20. So there's a 40 meters move here. So from 10 to the 12 second, you move by 40 meters. So this is the 140 mark. So you know the end point goes here. Okay, and then lastly, for the last 4 seconds, you move another 40 meters. So you add another 40, so 180 is your end point. Okay, now is the drawing part. So you know the respective points that they started off with. So you need to relate to how the car was moving. So here, you see that there is a uniform acceleration. Okay, or constant acceleration, but the speed was increasing uniformly at this point in time. Can you see uniform speed? Okay, increasing uniformly. Increasing speed, or rather speed is increasing uniformly. So when that happens, when we draw, you will draw that is increasing. It gets steeper and steeper, and technically it should increase at a uniform rate. Okay, but for this portion here, there was no acceleration. Your speed was increasing. Oh no, this one is increasing, not uniformly, my bad. Speed increasing at an increasing rate. Okay, then this portion here is where it's increasing uniformly. So that's why it's a horizontal line. Okay, then last part, it is decreasing. Okay, so it is increasing but at a decreasing rate. Okay, that's why we say that it's decelerating, right? So although the speed is increasing, but it's increasing at a decreasing rate. So when we draw that, the last portion, when you draw, it becomes like this. So the slope gets gentler and gentler. This one, the slope should get steeper and steeper. Okay, not the most perfect drawing, but you just need to show me that this part here is a curve. Okay, this portion here is a straight line. And then this portion here is increasing at a decreasing rate. So increasing. There's basically only these three types. Okay, then this is increasing uniformly or constant rate. This is increasing at. So when you convert the graph, this is how it looks like. Okay, last part. They ask for average speed. Yes.
I'm confused by the part you said that increasing at a decreasing rate.
This one. Because when we say that a car is decelerating, it is still moving, right? Okay, just that the increase rate gets slower and slower. That's why eventually it comes to a stop. Yeah, so it's increasing but at a decreasing rate. Gets lesser and lesser. Okay, so you must know how to convert the graph. Have they tested this in O-level for the past 5 years? Don't have. Okay, but in case they ask, you have learned it. Okay, average speed is total distance divided by total time. So total distance traveled, we know that there is 100 here, 40 here, another 40 here, right? So total distance is 180. Total time taken is the 16 seconds. So just go and find what is the average speed. Yes. Oh no, it was your plastic. Okay. Yes. I add 40 because for the second section is 40 meters, so I add the 40. Then the last 4 seconds is also 40, so I add another 40. Yeah. Oh no, we are talking about the total distance traveled for the whole journey, so it progressively go up. Yeah. So this one is one-way journey. This one they never say you go then you come back. So everything just goes further and further. Okay, but good question. Wait, 150 divided by 16, 11.25. So you look at, this is speed, right? So meter per second. So use the units accordingly, according to what you are given. So this kind of question, is it compulsory to see in the paper every year in O-level? Not necessarily. So there are years that they test, there are years that they don't. Okay, it's not every year they will have a question on this. It's just a real life question that may or may not appear. Okay, but you need to know. But your end of year will definitely have. I'm just saying O-level may or may not have. Yes. Yes, this one, increasing at an increasing rate. Yes, outwards. Like that. Okay, this one increasing at increasing rate. Okay, if you are ever confused, you try to draw tiny lines to remind yourself. Can you see that the slope gets steeper? Okay, but for this one, the slope gets gentler and gentler. That's why you know that the speed is decreasing. Okay, it's increasing but at a decreasing rate. Yes.
How do you differentiate, let's say like that?
This one is decreasing at a wait, this one and the other one, like this. You're saying this one, right?
The decreasing at
This
decreasing
kind. This one is the reverse. Okay, next example. Okay, so we move on to the next one. Oh, this one is acceleration already, right? Oh no, another context. Step function. Okay, later I talk about that. The last example is all that. Okay, step function is where it's disjointed. Can you see that there is no connection between here? Okay, when you see step function, but you zoom in, right? You see a shaded dot. So that means at this point it is a 1. But this is the excluded point. So your 1, your mass equals to 1. We take the charge to be $4 at this point, not $6. But if you go anywhere heavier than 1 kg, let's say 1.2, then you take the charge of $6 already. You move up to the next rank. But if you are at that boundary value at 1 kg, which price do you take? You take the shaded one. So you are being charged $4. So if you are at 2 kg, then you are being charged $6. Okay, if you are at 4 kg, then you are being charged $10. So take the shaded point as the end point. The one that is unshaded, you don't include that in the function. Yes.
So they won't charge a certain amount.
Yes. So you must look at which endpoint we are talking about. Okay? So this one you just do me again. Okay, for example, if I say my package weighs 4 kg, how much do they charge me? 4 kg is here, right? So you look, 4 kg, your graph cuts at 2 points. One is here, one is here. But which charge do you take? You take the part that is shaded. So $10, not the $18, because this point is excluded.
So if the package is 2 kg,
2 kg is $6, yes. Okay, so you look for the graph that is shaded at the end point. That is the one you want. At 1.2, no problem. You're here, right? So it's entirely on this line is $6. Yeah, it's only at the end point you need to be a bit more conscious for step function. Okay, the rest is quite easy to read. Okay, so I just wanted to address the step function endpoints, the boundary values. Yes. Correct, because the entire line, right, no matter 1.2, 1.4, 1.6, all the way until 2 is all $6. Okay? Can So we look at the question. It says, what is the charges to deliver 0.5 kg? So somewhere here, so just $4. Okay, 4 kg, that is where you need to think, because it cuts at 2 points. So 4 kg is at $10, not the 18. If it's 3 kg, it's right spat here in the middle, so it's also $10. Okay, so this one 10. Okay, next one. Oh, but company B also need to write. So this is for company A, the red graph, right? But if it's company B, is the blue graph. So 0.5 kg is here. Okay, so $2, you divide by 5. So each box is 40 cents. Divide by 5 box, right? So each box is 40 cents. So in this case, this is 480. Okay, and then for 4 kg is also at $10. So this is for company B, yes. Yes. Here, this point, right? 2 boxes. Because I figure out that one box is 40 cents. Because $2 divided by 5 boxes, each box is 40 cents. So 2 boxes is 80 cents. Okay? Yes. Yes, the one that is shaded. Okay, next one, it says company A charges how much dollars to deliver a parcel of up to 1 kg. So company A is here. Up to 1 kg is this point. So up to 1 kg, no matter what mass you are, they are going to charge you $4 for delivering the parcel. So that's $4, fixed $4. Then they say for the next kg, for that next kg or part thereof, that means if it's not the full kg, it is part of that one additional kg, let's say 0.2. 0.4, 0.6, 0.8. Anything that is part of that 1 kg, that additional 1 kg, they will still charge you the additional how many dollars? $2. So this is the additional part. Okay, then last, it says company B has a fixed charge of how many dollars? How many dollars? How do you find $4? Here? Yes. So this is the fixed charge. Meaning, even if I never deliver anything, as long as I engage their service, they charge me $4 first. So that is like the y-intercept. So fixed charge is your y-intercept. This one you learn in lower set. Fixed charge is at y-intercept. Just like you take the taxi you bought, they already charge you a fixed charge. Then per meter, they charge you an additional amount. So now every additional kg, how much do they charge you for it? How to find? Not exactly right. You see, every $1, it hasn't reached $2. So the way to find it is to go and find the gradient of this line. Then you can know for sure how much they charge you for each additional unit. So highest point is 16. Yes. Because gradient tells you the change of y per unit x. When you use y divided by x, you are finding the change of the y per x. So if you look from here to here, there's a rise of 12 units. You divide by a total of 8 units. So 12 divided by 8. It means they charge me every kg for $1.50. Okay, so every additional kg, they will charge me $1.50. Remember in Sec 2, they asked you, or was it Sec 1, Chapter 11, linear graph? They asked you to explain the meaning of gradient. You all still remember there's such a question? Then you need to tell me is the charge per unit change. 16, no, because the rise here is until 4. Not all the way until 0, because it started off here. Yes.
What do you do if you wanted 8 kg for company?
You wanted 8 kg for company. Just read from here. 18.
Oh, you don't have to read from the solid line.
No.
Oh.
You read the red line, because red line belongs to the company A.
It's the first line you choose.
No. You must read the correct line for the charge. Company A is all the red lines.
But if you buy 10
Company
kg,
B is the blue one.
But if you buy 10 kg, it's still the same price.
If you buy 10 kg,
It's still the same
it's
price.
cheaper to use company B because they charge you $16, but company A charge you 18. So you need to see which one is cheaper. Then they say a student commented that if you want to deliver parcels of masses less than 4 kg, company A will have a lower charge than company B. Do you agree? If it is 4 kg, okay, let me erase this.
Yeah.
I'm so sure, huh?
Because at 4 kg, they made a sale, so at max,
Okay, so we see, at 4 kg is this marking. At 4 kg, So which one is cheaper? What do you think? If it is between, if it is in this zone, between 2 to 4 kg, actually it's wiser for you to choose company what? B, because it has a lower charge. Okay, but between here, let's say up to this point, it sees, yeah. So if you look at this portion from maybe 1.4 kg onwards to less than 2 kg, it's actually wiser for you to choose company A. Okay, because company A is cheaper. Okay, so there are different range of values. We cannot say for sure that company A charges lower. So you have to tell them, is the claim true? You can say no. Okay, pick a region where it costs you more to choose company A. So it costs you more to choose company A if the parcel is between more than 2, cannot be 2 inclusive, more than 2 kg but less than 4 kg. It is more expensive, or company A charges, okay, has a higher charge. Yes.
If more than $8, then it's company B.
If it's more than, there is company B is cheaper. Yes, correct. Yes. No, you see, if I'm like, let's say 2.6 kg, can you see that company B only charge me $8, but company A will charge me 10? Yeah. So the graph is lying above that line, means it charges at a higher rate. Yes.
After less than 2 kg, it's like company A.
Yeah. So although partially her claim is correct, but we cannot agree with her totally, because there is a portion that is not true. So you have to counter her statement saying that no, it's not true, because there's a certain part that is a higher charge, although another segment of it is true. Okay, so you have to counter her statement saying that no, it's not true, because this portion is not true. Okay, but not saying that everything she says is not true. Partially is correct. Okay, so you could see real life questions like that where you need to read the graph and compare. So next time, if you all become some operations manager, then vendors will send you their profit, loss, or their cost, maintenance charge graphs, and then that is where you can compare and see when is it more sensible to engage them. Okay, so all the real life problem that you are doing, right, you will need to make decisions when you are arranging for any kind of events or trips, because you plan the budget. Okay, so that is for 4. Let's look at the next one. Yes. Because there are other parts, but I just need to locate one part will do to counter their statement. The rest of the part, you see this part here? This part, company A is more expensive. This part here, company B is more expensive. So all 4 sections, all different behavior. So you can quote the one that counters her statement. Yeah. Okay, next one. This one. Okay, it says the diagram shows the vertical uniform cross-section of 2 tanks, C and D. And then the dimensions are in meters. Both tank has the same length, perpendicular to the cross-section. And then water is pumped into the tank at a constant rate. So they say the graph shows the height of the water from the bottom of one of the tank against time. So which one do you think they are showing, Ken? Starting, it was constant. Then after that, it sort of increased at an increasing rate. Looks like this one, right? Looks like for this one. Okay, because for the first portion here, you know that it is going to increase uniformly. So this explains why the line is a straight line. Okay, but for this first portion here, you will realize that when you fill it up, it fills up. Okay, there will be a change in the rate. Okay, it could be increasing at a decreasing rate. Okay, because you have to fill more volume as you increase the height. Okay, but this one onwards, if we are looking at the top portion, it gets quicker and quicker to fill it up because you are filling up a smaller volume. So in this case, it will increase at an increasing rate. That's why it's going up like this. Sometimes the slope is not very obvious, but it will be a slope but not as straight as what you see in the black portion. So this one is for tank D. So you can say that for the height of 1 meter, the tank is of a uniform shape. Okay, hence the volume is uniform. Okay, therefore height of water should increase at a uniform rate. Yeah, when I increase, then become thin. Okay, but as it progresses, okay, beyond 1 meter, the shape of the container becomes narrower. Therefore, height of water should increase at an increasing rate. Okay, no need to be as long-winded as me, but the main point is to tell them that the first portion, the height of the water increase at a uniform rate. And then at the second portion, this is where the first part of the container is like that. Okay, uniform shape, uniform volume. You can say that. Yes. The explanation at most 2 marks. They won't want to kill you. They just want to differentiate you from the explanation. So they won't put a lot of marks in the explanation. Then the second part of the container is like that, right? So it gets narrower as the height increases. So that's why the height will increase at an increasing rate. Yes. Tank C, tank D. So the idea is for you to recognize and then let them know that you know that is this tank that is increasing uniformly, then increasing at an increasing rate. Yeah.
Next one. I think my height for tank C is increasing rate than uniform rate.
Increasing at a decreasing rate, then uniform rate.
Oh.
Yeah.
Just a question. For EOY, is it all the chapters we learn in Sec 2?
Yes. It just depends on whether we test until chapter 9 or chapter 10. Yeah. Might have some. Yes.
Chapter 5, right?
This one is chapter 5. Yes.
So you're on track.
90 marks.
90 marks total marks for end of year. Correct.
English, you don't know.
Yes, that's the next chapter
for the
after. Yeah. After this chapter, we will go into congruency, similarity. Then it will be trigo.
This email.
Yeah. Trigo, applications of trigo. So what is trigo? Tuakaso, Pythagoras theorem.
Cosine
3
rule.
new formula, sine rule, cosine rule, area of triangle formula. Then we will go into applications of trigo. So 3D trigo. If you have a 3D shape, look for the right angle triangle and do your tuakaso. And then bearings.
Isn't the EMF
Bearing.
AMF trigo. EMF trigo only look at 4 quadrant, 360 degree only. But your AMF can go many rounds. Yes. Okay. So last one, they ask you to sketch out this, the height increase. So remember for this one, the height of 1 meter, you should take not 20 minutes because the volume is half. Right, you half of this volume. Because this is the same rectangle but you only fill up half of it. So you won't take 10 minutes. You won't take 20, you only take 10. So to reach this height, we are increasing at a decreasing rate because as it goes higher, you need to fill up a bigger volume over time. So increasing at a decreasing rate, so something like this. You must show the slight curve lah. Okay, and then the last portion here, it is increasing uniformly. So you should see a straight line. Yes. Decreasing rate because if you go up, you need to start filling up a larger volume so it slows down. Yeah. Okay, and then the last portion, if we end off, okay, we don't know when it ends, but we know that eventually it should straighten. Uniform rate. Okay, maybe somewhere here is 2 lah. Okay, we don't know what is the time it ends because they never tell us the rate. Okay, but the last portion here should be uniform. Okay, increasing constantly. This one is increasing at decreasing rate.
This is on camera.
5. This is a real life application of graphs. This is? Yeah, recording.
This one.
Okay?
How do you know that it's half of?
Because you see the same rectangle. And can you see I actually half it? So I just took the time to be half of it. Then filling up the whole container. The whole rectangle. So you just need half the time. Okay? So you don't need to have the specific intersection points, but just a sketch will do because they only ask you to sketch the second one. So what we want to see is this part, you know, that is increasing at a decreasing rate. This part here is uniformly because the whole container is the same. It should increase at the same rate. Okay? Okay, last one is the matching of the graph. Yes. It's still increasing but getting slower and slower. Yes. I don't know what's the end time because here they never specify. So you just let it go as far as it can. Okay? Can Okay. This one. They give us scenario and they ask us to match it with the situation. So let's just try to find a match. A, they already match it for you. Okay, the petrol in the oil tank replenish steadily from 10 liters to 60. Okay, in 25 seconds. Steadily means uniformly. Okay, so they match the graph A to scenario A. So now let's try to find the match. I have B. Okay, wait, let me see if I can make this bigger. Which one looks like B? decelerate steadily from 60 kilometers per hour to a stop in 20 seconds. Graph F. Okay, so correct. So this one is for B. Or you can write here, graph F.
This one. How about
Yes.
Graph H. Graph H is also this side.
Must be one of them lah. Okay, we see mass of a newborn increases from 3.5 kg to 6.5 in 12 months. It increases more rapidly in the first few months. D increasing at a decreasing rate. So 3.5 was here, then probably 6.5, and then in 12 months time. Okay, so this is part C. So graph D. Okay, next one. A man burned 80 calories at a uniform rate in 20 minutes when walking on a treadmill. Burn 80 calories at a uniform rate. But uniform rate leh.
This one graph F, then the part B is H.
B is,
But it cannot go to 0 mah.
isn't it B?
A man burned 80 calories at a uniform rate in 20 minutes when walking on a treadmill.
B.
The y-axis is the number of calories.
Oh, so this one just go up lah, 80. So in 20 minutes. It burns mah, doesn't mean it must go down. Okay, the amount of calorie burn can go up also. So if this is amount of calories burn. Okay, the idea is the uniform rate. Okay, you must be able to see that it is a uniform rate. So this one is graph B. Okay, next one. When a piece of meat was taken from a freezer, its temperature increased from negative 15 to 10. So can only be this lah. Negative 15 to 10 degrees. Okay, cooled off at a progressive rate. So slowly until room temperature. So this is graph G. This is for part E. Okay, a cup of water cooled from 90 degree to 25 in 40 minutes.
C.
Okay, so this one is progressive. So this is graph C. And then this is part F. Okay, water level in a burette increases at a uniform rate from 5 to 20 in 10 seconds. Then decreases at a, this one, right? Has to be this. Graph H. Last one, heart rate increase 70 beats to 120 in 2 minutes. Kept at the same rate for next 8 and then stop, resume. This one. So you know the behavior, how the graph can change drastically. But the idea is increasing at an increasing rate, decreasing at a decreasing rate, increasing uniformly. These are how the shapes can change.
This one.
Yes.
So for graph A and B, right?
Yes.
For graph A, how do you know whether it doesn't start from 0?
The question will tell you, maybe like you start from a certain temperature, then it started increasing. Okay, so if we zoom into the graph, right, there's certain portion that I think we can try to visualize. This one is definitely increasing, but it's increasing at a decreasing rate. So we want to know how the shape looks like, that's all. What about this one? It is decreasing. For sure it's decreasing. But what kind of rate? When you are stuck, try to visualize the gradient line. Is it becoming gentler? Decreasing at a decreasing rate. So although it is dropping slower and slower. So decreasing rate. So you look at the shape of the graph, it's just a reverse shape. And then any other shape we need to be wary of, don't have. I think this is about it. The rest are all uniform. Okay, this one is decreasing at a decreasing rate. This one. Yes. Curve outward like that. Okay, so you imagine the gradient. It gets steeper and steeper, right? So this is decreasing at an increasing rate.
So it's reducing but at a fast.
Yes, correct. Increasing rate. So take note of the difference. So whenever you are stuck, when you are drawing, right? If you don't know whether it's increasing or decreasing rate, then you go and draw the slope to determine whether it's gentler or what.
Decreasing at an increasing rate, is it like
20
20 to 15
to?
15 to 10 to
Yeah, gradual lah. Becomes gradual. Okay, so
the rate is basically the steepness.
yes, the steepness of the gradient. So you see this kind got 3 types lah. So if they say different behavior, you just know how roughly the sketch will be. But uniform is definitely like that. Uniform increase, uniform decrease. Okay, no other patterns.
For the question,
Ah.
they said that increase from 17 grades. Yeah. But they never told like uniform.
Ah yeah, okay, that's the downside. They could have improved the way they phrase it. Yeah, but we know the graph behavior like this. Yes. Not uniformly though. Oh, this part is uniformly. Okay, they should have put uniformly. Yes.
For decreasing at an increasing rate,
Yeah.
like 20 to 19 to like
Can lah, you can visualize like that. So gradual. So can you see the slope becomes gentler and gentler? Per minute, the change becomes lesser.
so like 20 to 15 to 30.
13 to 12 to 11 point something. Yeah, slower. Okay? So these 3 scenarios only. Okay? So this is the whole over.